Hello and welcome to this C programming lecture on external and static. So what is extern or external? External variables are declared outside of any function scope and contain the extern keyword as a prefix. Variables that are typically defined with the extern keyword have been declared, but they haven't been defined. So usually you'll have these things in header files or other different translation units like that you're compiling against. So really it's just letting you know that there is a particular variable that is externally accessible or externally declared in a different segment of code. So here's an example of a program that expects an A variable to be an external variable. We can see here that when we try to compile the program, there is actually an undefined reference to an A, and that is because a variable A has not been actually defined. So that being said, what we can do is we can include a extern.h header that we created locally and have it actually declare a extern a variable. So in this particular instance, this header file could contain a variable a that would assign the variable a to the value 100, which is why when we print out a here, it would actually print out the value 100. So again, this is just letting you know that this variable is not declared within this file, but it is external to this particular file, and it's probably defined inside of our extern.h header. So here's some additional information about external. External variables, like I said before, they could be defined inside of libraries. However, this can lead to a lot of confusing code. It's generally best to just know how to use it. Especially when you're new to it, just explore how this keyword works by creating different types of, either extern or static or, auto variables or whatever. So a variable can be declared as extern, and it also can be initialized. It's often better to experiment with these keywords, like I mentioned, just to get a better understanding how they work. So functions by default will use the extern keyword to allow for external storage. However, we can make functions or variables non-visible by using the static keyword. Now, what is static? Static keyword holds various different contexts. I just described one context that it has, but it all is dependent upon how we use it. But at the context, in the context of a function, like we described, the static variable is defined and initialized once during execution and remains that value until it's been updated. However, it persists throughout the duration of the running program. So this is in the value in the context of the inner scope of a function. So in the context outside of a function, it makes the variable visible it only makes it visible to the linking step, therefore making the variable non-visible to any code that's attempting to link with it. So it just basically will say, okay, it's like as if it's making it internal to that particular translation unit. So the static keyword can be applied to both variables and functions. Here's an example of the static variable. So a static variable inside of this test variable, you can see here that we are calling this in a for loop, and this we are just continuing to call it 10 times. We initialize the x static variable to 0, and you can see that over the for loop we're actually incrementing our static variable. So you can think of this as typically I like to think of this as a local persist. So this value will persist because it's a static variable. And you can see the output on the right. All right, so static functions. Okay, so this one's a little bit more confusing. What we can see here is that we have two different functions. We've kind of seen this translation, this code before when we were talking about libraries and different types of linking. So what we're doing is we're actually creating our static magnitude. So this magnitude function is actually should not be accessible when we compile this code during the linking stage. So when we print this vector, this will resolve properly because we're calling it internally. However, if we attempt to call magnitude externally, it would fail. So all of this code should seem relatively familiar. We've seen it before. So here is me attempting to run this program. So here's all the compilation steps. We're actually compiling, creating a shared library, creating a static library, linking against that static library, and then running. And you can see this is the result we expect. Now, let us try to call magnitude. So here's an example again of us trying to call the static function magnitude. Now what happens? Now you'll see here that we say, okay, well, here's a particular, magnitude static function, but it's never used. So we create this. First we create our actual our O file, our object file for our library. Then we create our object file for our particular main.c file, and then we try to actually we just do this to see what warnings we get, right? So we or any errors. So we don't get any errors when we compile this, so everything should be fine. We go on to the next step. The next step, this is not necessary, but just to remain consistent, we're creating a static library. And then we try to recompile or just compile our actual program using that static library. And you'll see we get the same warning as when we made our .o file. So when we attempt to actually link, so when we get to the actual linking step, because remember up here, this just creates the O file. It doesn't try to patch in any code. Down here, our last line, it actually attempts to add in code. But you'll see here that when it does that, it just says undefined reference to magnitude, and then LD, which is the linker, has returned an error code. So this is just really a way for you to understand that like I was saying, adding static to the front of a function actually makes it an internal translation unit, so you cannot access it outside of that particular piece of library code. Okay, let's go ahead and recap static and extern. The keyword extern can be used in order to explicitly define a variable or function that is external, so this can be done with libraries as well. The keyword static has a variety of different meanings depending on how it's used. Static and variable declaration within a function retains its value throughout the program. I like to think of this as local persistency. A static variable declared outside of a function is local only to the object file created from the .c file. So we didn't really see an example necessarily of that, but try this out for yourself, and mess around with these different capabilities of what you can do. And then another use case of static, and we did see this, was when a static function is declared internal, it is declared internal and is only local to that object file. So again, you can see kind of how we can just lock things down and make particular translation units what they are called opaque types, so you can't actually see certain implementation details. So let's go ahead and jump into some code and mess around with some extern and static stuff. Okay, let's go ahead and look into some coding examples using external and also static. So first and foremost, we're going to create our main.c file. Go ahead and open up that guy and do our basic hello world example to just ensure all of our stuff is working. A little dull at this point. I'm sure you're probably getting a little sick of doing it, but again, it's just kind of a good habit to develop. All right, so let's start out with extern. Now, kind of the example that we showed before was we had two different files. In this particular case, let's go ahead and create our touch extern.h. And we're going to go ahead and open up extern.h in here. And let's go ahead and define a int x and set it to 100. just like our example. And what we're going to say in this particular file is we're going to include our extern.h file. And within this file, let's go ahead and also do this. We're going to say we have something external to this program. This is going to be the variable x. It's going to be int x. All right. So this is all that this is being defined inside of here, there, and then we want to say print x, id x, something like this. Let's go ahead and compile this program, run the program, and we can see it's similar to our example that we showed in the slideshow. So again, really all that's happening here is that we're just saying, hey, this is external to the program. Now, if we were to kind of break this out into a different example, for instance, let's just say, you know, this was inside of some type of actual C file that we compiled in to an OBJ file and then included. You know, that would also work as well. So we can go ahead and create a concrete example of that as well. So let's just do extern.c and just to remain consistent. So we're going to say extern.c, open that guy up, and we're basically just going to take this guy's code out, place it in here, and we really don't need a header file at this particular point. So get rid of that. We can go list out the files. Let's go ahead and get rid of our binary, get rid of our extern.h, because we don't really need that. All right, great. So GCC, we're gonna compile our O file, and we're gonna pass in the extern.c, and that should give us extern.o. So that's exactly what we expect. Now, when we compile our main.c file, we need to pass in our extern.o file, and we can see that the same result occurs. So again, it's really just how you want to look at the particular problem and how to solve it. You know, compilation is not something that needs to be confusing. You can simplify it vastly if you just kind of understand some of the mechanical parts and how it works at a higher level. All right, so this is how the extern variable works. Next, let's go ahead and move over to the static variables and perhaps functions as well. Okay, let's go ahead and get into the static variable. So let's start out with a real simple example. Again, main.c, we're going to go ahead and open up this file, go to main.c. And we're going to go ahead and make just our regular old program once again. Just go ahead and do this int main. You can type properly. All types of typos, that's all right. Hello world. Okay, so again, just like the prior code example, we're doing the hello world just to make sure everything's working once again. All right, so now what we're going to do is we're going to just simply create a static variable inside of a function. So let's just call a function, we'll just say this and maybe call it func. And you know, func maybe just does nothing really, or at least nothing that we can see, kind of like our other example. So it's basically a function that returns nothing and takes nothing, which is kind of interesting to say. All right, so static, we'll just x 0, and again we'll just increment x, and let's just output x every time. All right, so x /m and x. Okay, so we can call this, you know, let's just say func, call it like that many times. No loops, just static calls. Oops, I forgot a actual data type. Okay. All right, so there we go. Kind of what we expected, something that we've seen in the prior examples. All right, so again, typically what I personally like to do is I'll make a define statement, and in this scenario, I'll make something called a local persist, and then have it static. So that way, when I come into this variable and I want it to be local persist, this gives it this static keyword some context. Now that being said, I'll also do like a global variable static, like so. So that way, it's the same exact thing. It just changes context. So maybe we use, you know, a global variable. We create static and we say something along the lines of like my gvar, something along those lines, and we can call it an int. Maybe it's assigned to -1 or something. Anyways, this just to show you how I would set it up. I will leave these out and just keep it kind of the easiest way to reconcile inside your head. All right, so we'll just leave 2 function calls there. And now let's start out with a little bit more complex problem, I guess. So what we want to do, let's go ahead and just make a file. Let's just call it greet.c. And let's go ahead and open up greet.c. Let's split this and let's move this. We can keep this here and move this one over here. Why not? All right, so in here, we're going to do stdio.h. We're just going to have a nice function that takes nothing and returns something, and we're just going to call it greet, something that we've done previously. And we're just going to say printf. Matter of fact, let's just do this, x. Yeah, let's just do x. Hello number, hello number, %d, and x. Again, real simple. All right, so, and again, we can do something along these lines. We can say, oh, perhaps we have a static, oh, let's not do that first. Let's do this. So we'll say, let's say we have an int x, and we'll, again, make it 100. Now inside this code, we can go ahead and we'll just leave this. And what we're going to do is we are going to create a header file, gcc, touch, and we'll say greet.h. And we're going to go ahead and open up greet.h. Oops, don't save. Code greet.h. This is what we want. And inside of there, we're just going to use this prototype here, right? This void greet. And it's going to take int x like that. This is our function prototype, which we will actually now need to include inside of here, which will be greet h. Okay, great. And now what we can do is we can say extern, right? Extern int x. And perhaps at this point, what we can do is let's just stick to this example. What we'll do is compile our, let's remove our a.out file. Okay, so we have a greet h, great. So gcc-o, let's compile our C file for greet. So actually, oh, I'm sorry, gcc-o-c greet.c. And there we go. So now we have a .o file. Now inside of our main file, we'll just kind of push this guy back over here. Let's go ahead and call our greet function, which should be defined inside of our greet.c, .o file that we're going to link against now. So GCC inside of here, what we're going to do is we're going to just say main.c, and then we're going to pass in our greet.o. Now, what we can see is we forgot to pass an actual variable. So let's actually pass our extern x variable. Now that's going to be kind of interesting. So what we're going to say is gcc main.c, and then we're going to pass in the greet.o. And we can see now when we run it, it actually prints out the variable that was defined externally. Now you may have seen me make a slight mistake there a second ago, and that was because when I compiled, you'll see in our history, I compiled without the .o file, so that's just the reason why it was yelling at me. It has no idea what these things are because the .o file doesn't exist. So what we need to do again is just actually include the .o file like this, and everything works. Okay, great. Now, what would happen if I made this static? Okay, let's go ahead and find out. GCC main.c. Oh, let's recompile. Okay, remove our a.out, remove our greet.o, and let's do gcc -O-c greet.c. Okay, got a new .o file, a nice object file for our greet file. And now let's go ahead and recompile our main.c program using the new greet.o file. Now you'll see, because I've defined this as static, it's only internal to this particular translation unit. So following along the lines of what I was just saying, you know, I'll define something that I'll do a multiple define. So I'll have a local persist that's static. Perhaps I'll do a global variable static, and perhaps also I'll do like an internal variable static. And depending on where you use these, the context changes, right? So you won't typically know. So we technically cannot access X, even though it's defined, you know, we say this is defined externally. So you can't have this set as static. So I just wanted to show you that. I'm going to go ahead and delete that, so that way it doesn't break the rest of our program. So if we recompile our greet.c file and then attempt to recompile our actual program using that .o file, everything should be fine again. All right, perfect. So again, this is kind of the stuff that I'll use. You don't need to use it, just, you know, kind of understand what these static keywords mean. So in our next example here, what we're going to do is say greet maybe v2, but instead what we're going to say is this is static now. So instead of being able to we won't be able to directly access that. So typically here, this is where I would use my internal static. So instead of it saying static here in my programs, you'll see something that will say internal, right? And you'll see why I name that internal here in a second. We're going to say X, and it's just going to be the same exact output, except at the end, we're going to say hello from v2, number, something like that, right? Okay, so inside of greet, we can actually call our greet v2 and pass in the same value here, greet v2. And the reason why we can call this is because it's in the same exact translation unit. So the problem is that this guy will need to be moved up one, because this particular function will need to know that it exists prior. And then now what we can do is pull this into the header, but it's not actually going to work, you'll see. So what we're going to do is, for the time being, let's just switch over to greet v2, compile our program. So we're going to remove our a.out file, we're going to remove our .o file, and now we're going to recompile our greet file. So -O-C greet-c, like so. Now we have an O file, so let's go ahead and attempt to compile our program, and you'll see here that it cannot find this greet v2, and that is because it is a static function. You've seen this in the example. It kind of shows here that you can't actually do that, because just like the other variable that was defined as static that we thought was we were expected to be external, it's internal to that translation unit. So static again has a different context of depending on how you use that keyword. It's important to kind of understand these things, and the best way to gain intuition about it is just use it. All right, so the way to fix really this is just don't use it at all, and there we go. And you'll see once I don't need to recompile the .o file. All I need to do is just recompile my main C file, and now that I'm calling it the different function and everything works, you'll see that the internal function call from greet.c, the actual greet function actually calls v2, so that all works.